Okay, number 17 on page 336 is a lot easier than it looks. It's just a matter of getting started. The hardest part is figuring out what the hell they're talking about. But once you've figured that out, it's a matter of doing stuff that you've already done many times. So it says that you're looking for the maximum vertical distance, d, between the parabola defined by this, which is this line here, and this line here, which is the straight line. So if you look at the vertical distance between any point on this line and the corresponding curve up here, as x gets greater from here to here, the vertical distance here gets larger and larger to a point about here, somewhere like that, where it then starts getting smaller and smaller and smaller. So it says that d is the difference between y on the curve and y on the line. So the best bet is to forget this. Forget it even exists. Don't even look at it. Just look at the numbers. D is the difference between y on the curve and y on the line. So let's do this again. Y equals negative 2x squared plus 4x plus 2. That's the curve. Y equals x minus 2. That's the line. So any y, we'll call this y on the curve and y on the line. The distance between, it says, is called d. So d equals y on the curve minus y on the line. Okay, now we can look at this again. The y value of any point on the line subtracted from the corresponding y value for any point in the curve that's right above it. That's what d is, the difference, the distance, and it's looking for the maximum distance. So let's sub in this stuff for y on the curve and this stuff for y on the line into this formula, and we get negative 2x squared plus 4x plus 2, which is y on the curve, minus, we'll put that in brackets just to show that it's together, minus y on the line. That's just these two values here shown as their x correspondence here. So if we put this together, we get negative 2x squared plus 4x minus x, so plus 3x, plus 2 minus minus 2 is plus 4. That looks surprisingly like one of these kind of functions. Right, it opens downward because it's got a negative 2 right there, and we know that this is some kind of a parabola. And given that, remember this is distance, we're looking for the maximum distance, so we're looking for the maximum, we're looking for the vertex. And when we get the vertex there, h comma k, you know where this is going now, the maximum distance would be given by that value there, which is k in that formula. So I'm going to show you two different ways of determining what that is. This is a simple quadratic where we locate the vertex and find out the y value of that vertex. Two ways to solve it. One way is invoking y equals ax minus h squared plus k. You remember that standard form, and if we can convert this into that format, we'll find out what k is. And the other way comes from something that you've long ago forgotten, as any sensible person would, known as the vertex formula. So this is section 5.5 from way back when. It's in page 245. The vertex formula, if you've got a function, as long as a doesn't equal 0, so that expression doesn't equal 0. So you have a parabola and the vertex is given by that value for x and this value for y. Remember, we're only looking for y, so we're only looking for c minus b squared over 2a. So have a look at page 245 if you need to. So c minus b squared over 4a would give us our value, the y value of this coordinate here. So this is the easier way to do it, but in order to do it this way you have to remember the vertex formula, which any sensible person would have forgotten. But c minus b squared over 2a, that's c, so that's 4 minus b squared, that's 9, 3 squared is 9, over 4a. 4 times negative 2 is negative 8. So the negatives cancel out, and we get 4 plus 9 over 8, so it's 4 plus 1.125, and that equals 5.125. That was easy, and that's actually the answer. This other way of doing it involves manipulating this into this formula. So the way to do that would be equals negative 2x squared plus 3 over, no, sorry, that's minus 3 over 2 plus 4, and what I did there was I just sectioned this off here, and then I pulled the minus 2 out of it. And I left some space here because we're going to turn this into a perfect square trinomial. So that was 2 steps in one there. I suppose the intermediate step would have been to put the brackets around this and then pull the minus 2 out. So I pulled the minus 2 out of this, and it gave me this here. So we need, in order to make this a perfect square trinomial, we need numbers that add up to 3 over 2, and we need that number squared over here. So it's x squared minus 3 over 2. So half of 3 over 2 is 3 over 4. And 3 over 4 squared is 9 over 16. So I know that these are fractions and it's all very complicated, but 3 over 4 times 3 over 4 equals 9 over 16, and that's why we get 9 over 16 over there. And 3 over 4 plus 3 over 4 equals 6 over 4, which equals 3 over 2, and that's why we use 3 over 4. Okay, so this becomes B and that becomes C. So we take this, which is negative 2x minus 3/4 squared. That's what that is. What we did is we added 9/16. We added 9/16, which is going to be multiplied by negative 2. So negative 2 times 9 over 16 equals negative 18 over 16, which is 9 over 8. So if we added it, if we subtracted 9 over 8 here, we're going to have to add 9 over 8 here. And that means plus 4 plus 9 over 8 is 5 1/8, which is the same as 5.125. Was that confusing? It almost confused me too. But what that is, and that's a hard way of doing it because you're dealing with fractions, but you do end up with the same value of 5.125.